Okay, welcome to this class of physics, and we are discussing about electricity. We had already discussed about Ohm's law, and we all know that Ohm's law is given by the expression V is equal to IR, where V is the potential difference. You know the potential difference, we have already discussed it in our earlier classes. Okay, and I is the current flowing through the conductor, electric current, which is Q by T, and R is called the resistance of the conductor. So that all we know about. Today we are going to discuss about this V is equal to IR from another point of view. Suppose we have a graph such that you already know that a graph consists of axis, and suppose we take two axes, the x-axis and the y-axis. So suppose this is the x-axis and this one is the y-axis, and on the x-axis we are going to plot values of current, and on the y-axis we are going to plot values of potential difference. Okay, so suppose we are going to do this for a resistance whose a resistor whose resistance is known to us. Suppose this is a wire which has some resistance, say R, and some current we shall flow through it by applying a potential difference across its ends. So the ends of this conductor are A and B, and we are going to apply some potential difference between the ends of this conductor, and we are going to change that potential difference, and as we go on changing the potential difference we shall see that there's going to be a change in the current also. So we already know that from Ohm's law. Suppose the resistance of this conductor is 100 ohm. Okay, and after this we are going to do this experiment. So what we are having is, now we are having a situation where there is a box, and in this box we are going to put some values of V and I. The primary value will be the independent axis has I on it, so we shall take I as the independent value, and we are going to put V, we are going to calculate V accordingly. In practical way, actually we apply potential difference and we measure the current, but that can be done the other way out also. So let us say that we are having a current of say 2 ampere flowing through this. Then if it is 2 ampere, we shall have a potential difference of what we can easily calculate. So V is equal to I times R, as Ohm's law says. So V is equal to I is 2 ampere, 2 ampere multiplied by the resistance, that is 100 ohm, and so that gives us equal to 200 volt. So 2 ampere corresponds to 200 volt of potential difference. So that we can write over here now. So this is 200, right? Instead of 2 ampere, if we had a current of 1 ampere flowing through the wire, then we would have got, as you must have already calculated it in your minds, it would have been 1 into 100, and that would give us equal to 100 volt. So that is very easy calculation, isn't it? Because we already have Ohm's law with us, that is V is equal to IR, and hence this will be 100 volt. If we had 0 ampere, that means no current flowing, obviously we would have seen that if we put 0 in place of I over here, then V also becomes 0, right? If we would have, suppose something like 1.5 amperes, then what potential difference we would have got? So 1.5 V gives us V is equal to 1.5 ampere, 1.5 times 100, right? And that 1.5 times 100, as you must have already calculated it. It is so easy. It is 150 volt. So in this way we can see that different values of current can give you different values of potential difference. In practical life, however, we actually apply the potential difference. The potential difference is known to us and the current is measured when the experiment with the Ohm's law is actually performed in the laboratory. We apply a certain values of potential difference and the corresponding current values, we measure it using ammeters, and then we can calculate the ratio or draw the graphs. So suppose we have here, this is 0, this we can take as 1 ampere, and this we can take as 2 ampere, right? And this we will take as 100 volt, and this place we will take as 200 volt. So that is the situation in the graph now, and we are going to plot the points. That is very easy for us to plot. So 2 on the x-axis, that is here, because you must have already kept in mind that I is on the x-axis and V is on the y-axis. So when you take the value of current that is on the x-axis as 2 ampere, which is over here, then the corresponding value of y is 200, which is over here. So the corresponding point that represents this pair of values is this. So this point represents the 2 ampere 200 volt situation that we are looking over here. Similarly, for 100 we have this 1 and this 100, so this is the point that represents it, right? And then we have 1.5, which will be between 1 and 2, and 150, which is between 100 and 200. So again, this is the point that represents it, and then 0 0, this is the point 0 0, so this represents 0 0. So that is the situation. Now if we try to draw a straight line through this, what is going to happen? So if you draw a straight line through this, like this, the line will be drawn. Okay, so it will be a straight line showing that indeed V and I are proportional to each other, and this line gives us the look of the resistance, which is a constant value in this case. And this graph that we have drawn over here, this has got a beautiful name, and it is called the VI graph, right? So it is called the VI graph, and it is used to understand the nature of resistance of the conductor or the resistor or the device. And let me tell you one more thing, that although this is the Ohm's law, this Ohm's law does not apply to conductors in absoluteness. That is, the conductors may follow Ohm's law for a particular range of temperature, but after that particular range of temperature, conductors usually tend to deviate from this Ohm's law, and we then see the graph not going straight. To some extent it goes straight, and after some time, after a certain potential difference, when the wire starts get heating up, we see that this graph actually does not go straight and it turns, it deviates from the straight path, showing that from that point onwards it does not obey Ohm's law as it was earlier doing. So that was the discussion about the graph pertaining to Ohm's law, that is the VI graph, that helps us to understand V is equal to IR, that relation of Ohm's law, with much greater ease. Thank you.